In this video, we're going to look at three important properties of logarithms, and a lot of these properties and topics we've been talking about in the past few videos are going to really be important once we get to the end of this chapter, and we're going to look at how we can solve exponential and logarithmic equations. So these three properties are going to be very important, so make sure that you memorize these. We start off with log base A of u times v, which says if you're taking the log of two things being multiplied together, where u times v is multiplied, then we can split it up into two separate logarithms by writing it log base a of u plus log base a of v. Now the key thing is here, when you split this up, you're going to have the same base. So when you look at multiplication, we can split that up into addition. And if you look at number 2, log base a of u divided by v, if you're dividing two terms, then we can split that up into two separate logarithms using subtraction. Okay, so that's the only difference here is if you multiply, we can split it to addition. If you're dividing, we can split it into subtraction. And the third property says if you have log base a of u to a power of n, then we can take this power, or the exponent n, and we can multiply the n out front of the entire logarithm. And then we would be left with n log base a of u. For these first two properties that we have here, u times v goes to u log of au plus log of av, you can kind of think of that in a way like your rules for exponents. The way you can remember this is what happens if you're multiplying x cubed times x squared. When you multiply, what do? We add exponents together. Or if you were to have x to the 7th over x to the 4th, when we divide, we subtract the exponents. So here you would have 3 times 2, which is x to the 6th, and here you would have x to the 7 minus 4, which is x cubed. So if you keep in mind, when we take the log of something, what are we finding? We're finding the exponent. So it kind of makes a relationship over here. What do you do with exponents when you multiply? You add. So here when we take the logarithms, we're going to add them together when you are multiplying. And when we're dividing, we're going to subtract, just like we would our exponents. So let's look at a few examples here. We want to expand the logarithm, okay? So we have log of 4x. So this is log of 4 times x. So we could use property number 1, which says we could write this as log of 4 plus the log of x. And right now you may not see quite an advantage of doing some of this, but this way we can kind of simplify the logarithms, and these are techniques that we will use later on in the chapter. And especially if any of you go on to take calculus, you'll use these properties as well. All right, log of 8xy. Well, here we have three things multiplied. So up here the property only shows 2, but we could certainly extend it to 3. So we could actually just split it into log of 8 plus log of x plus log of y. Again, it's all multiplication, so we're going to rewrite it as each one being added together. All right, now we want to look at the second property. Here we look at division, log of 8 divided by y. So we could take and split that up to two logarithms. So we could take log of 8, but this time because of division, we're going to subtract log of 8 minus log of y. And then we have natural log, and again, it doesn't matter here. We have the natural log of x over y. So once again, we could write this as the natural log of x minus the natural log of y. Now, if we look at using property number 3, here we are dealing with our exponent. We have log of x cubed. Well, property 3 says we can take this exponent and multiply it out front of the entire logarithm. So we would end up with 3 log of x. And the other example over here on the side, again, we could take our exponent, we could take the 4, and even though there's a number out front, we would just multiply that. So 4 times 2, we would have 8 log of x. Now, if you look at the next example below, and maybe you want to try this on your own, This one's going to actually put a couple of the properties together. We have log of xy squared. Well, the first thing we want to look at is we're multiplying. So that's kind of the main operation here. So the multiplication we can split into two logarithms as log of x plus log y squared. All right, now we want to keep simplifying until we just have one piece like log of x. We just have the one variable, the one term. So this piece is okay. But now we want to rewrite log of y squared. We want to get rid of the square, and that's using that property number 3 where we can take the exponent and move it to the front. So we would get 2 log of y. Now once again, you know that you've simplified this when you just simply have log of one piece plus the log of another single piece. All right, here's another example of looking at some of the properties combined. And again, you may want to pause the video to see if you can try this one. We have the log of 4x divided by y. So the main operation here, and there's a couple ways we can look at this. This can be a little tricky. We have 4 times x on top, but then we're dividing by y. So we could think of this as the main operation as division. And we could first start by writing log of 4x minus the log of y. And then we'll notice that because this is the log of 4x, this is multiplication, so we could certainly split that into addition, and we would have log of 4 plus the log of x minus the log of y. Okay? And that would be your final answer. Now, there's another way you could look at this problem. If you want to try to do this problem in one step, you could look at this and say, all right, we're going to start off and split this up. We have the log of 4 times x, so that would be the log of 4. Because it's multiplication, we would say log of 4 plus the log of x. And then because the y is on the bottom being divided, it would be minus the log of y. So if that's the easier approach for you, you can do it that way, or if you prefer the first method, either way is perfectly fine. Now, you got to be careful with this next one. This looks very similar. If you notice, this is log of 5 over xy, whereas the previous example we had log of 4x over y. So we're multiplying on top, dividing by y on the bottom. So make sure you notice the differences between this example and the one we're about to look at here. A lot of times students will make a mistake with this division and the multiplication of xy here on the bottom. So I'm going to start off with the main operation is division, so we could split this into the log of 5 minus the log of xy. And now we know we can leave the log of 5, that's already simplified. And this is sometimes where people will make a mistake here. We have minus the log of xy. And this is minus, and I'm going to actually put a parentheses here because this minus is subtracting the whole log of xy. So if we split up the log of xy here, this then would become log of x. And because it's multiplication, we would use addition, so that's log of x plus the log of y. And now if you notice, why did I put the parentheses here? Because this whole log of xy, which the log of xy here, that simplifies to this piece, which all of that has to be subtracted. So that means if we were to distribute the negative, we would end up with a minus log of x minus log of y. And this here would be your final answer. Now let's look at trying to perform this in one step. If we look at the original problem again, if we try to do this in one step, we would have log of 5, okay? And now because we're dividing by the x, that would be minus the log of x, okay? Now this is where sometimes people make a mistake. And you're like, well, okay, the y now is being multiplied. Well, the y is being multiplied with the x, but it's being divided by the 5, so that's why if it's on the denominator being divided, you're going to actually subtract it, and you have a minus log of y. Okay, and now again, this is where a lot of people make a mistake. They want to say plus because they see the x and y being multiplied, but realize the y is in the bottom, so therefore it's going to be a minus. Okay, so be careful when you have multiple things in the denominator if you have a fraction where you're dividing. So one way to easily remember this, if you notice here, the two terms that we have here, x and y, are in the denominator. Here you have your x, here you have your y. That means you're going to be subtracting them away. Anytime you have a term in the numerator, it's going to be addition because you're multiplying. If we go up here and look, here we had 4 and x in the numerator, and that's why when we look at the answer here, it's 4 plus the log of x. Log of 4 plus the log of x. So if it's in the numerator, you're going to be multiplying, which means you're going to be adding the logarithms together. All right, here we have another example of each of a couple of the properties. And again, you could do this in one step. This one I'm going to actually split into two steps here. First, we have the main thing is being multiplied, 2 times x cubed times y to the fourth. So I would split this to the natural log of 2 plus the natural log of x cubed plus the natural log of y to the fourth. So that takes care of all the multiplication. Now all we have to deal with are the exponents. Well, we're simply left with the natural log of 2 plus, and now the 3, the exponent can come out front, so we would have 3 natural log of x plus the same thing with the 4 would come out front, and we have 4 natural log of y. And again, notice we're taking the natural log of one piece, the 2, the natural log of x, and then simply the natural log of y. All right, now here we have one that's a little bit more involved. We have the log of the cube root of x to the fourth over y to the seventh. Now, quickly here to the side, I want to review a little bit. If we have the square root of x, that's the same thing as x to the 1/2 power. Or if we had something like the cube root of x, we could write that as x to the 1/3 power. Or if we had something like the cube root of x squared, we could write this as x to the 2/3 power. So I want to remind you, if we have a square root, a cube root, or any nth root, how we can rewrite that using a fractional exponent. And that's what I would recommend here with this example. I want to start by taking and writing this as the log of x to the fourth divided by y to the seventh. Instead of the cube root, I want to raise this to the power of 1/3. And hopefully now you can see what we can do with this exponent. We can take this exponent and we can move it to the front, and that's our property number 3. So we would end up with 1/3 the log, and I'm going to actually put a bracket here because this 1/3 is going to be multiplied by everything. 1/3 the log of x to the fourth over y to the seventh. And you'll see why in just a minute why I wanted to use the brackets. So now we're going to leave the 1/3 alone. And now we just look at log of x to the fourth, y to the seventh. Well, here the main operation is division. So we can split the division into subtraction. So that's log of x to the fourth minus the log of y to the seventh. And then we can take care of the exponents. Now, hopefully you can see why I had the brackets with the 1/3, because this 1/3, remember, is to the whole logarithm. And if I split the x to the fourth over y to the seventh into the two separate pieces, this 1/3 has to be applied to everything. So that's why we have to include the brackets here. So we have 1/3, and now we can take the exponent 4 and move that to the front of the logarithm. So that's 4 log x, and the same thing with the 7, so we get 7 log of y. And this here would be your final answer. Okay. Now, if you wanted to, for some reason, you could actually distribute the 1/3, and if you distribute the 1/3, you possibly could end up then with 4/3 log of x minus 7/3 log of y. But probably the better answer is leaving the 1/3 factored out front. Because most likely if you came up with this answer down here in green with the 4/3 and 7/3, you would probably factor out the 1/3 anyhow. All right, now we want to look at how can we use the properties instead of expanding, how can we condense the logarithms to one log function? So in other words, here we're doing just the reverse of what we were looking at earlier. So now we want to use the properties to go in the other direction. So here we have 2 log of x minus 3 log of y plus 1/2 log of z. And typically you want to start with your exponents. So we're going to do the reverse. And now we're going to move the 2 up to our exponents so that we would get log of x squared minus log of y. Move the exponent up, so that'd be y cubed. And then here we would have the same thing. If we move the 1/2 up, we would get plus the log of z to the 1/2. And now we can go back, after we have taken care of the exponents, we can go back now and think of combining these together. Now, we have log of x squared minus log of y cubed. So we could think of this as the log of x squared, and because it is being subtracted, minus the y cubed is going to go on the bottom. We're going to divide by y cubed. And now it's plus log of z to the 1/2. Because it's plus, once again, that's going to go in the numerator. So that would be z to the 1/2 power. So again, if it's multiplied, it goes on the top. If it's dividing, I'm sorry, if you're subtracting, your piece is going to go on the bottom. If it's addition, then it's going to go on top for your multiplication. Now, if you want to, with this example, this answer is perfectly fine. If you prefer to rewrite this, you could certainly write this as the log of x squared. And instead of z to the 1/2, we could write this as the square root of z over y cubed. Okay, either answer here would be acceptable. I don't really care if you leave it as z to the 1/2 as a fraction or if you change it back to a square root. Now, pay close attention to this example, and particularly how we handled the subtraction. We had x squared over y cubed, and then the addition. This is the part that sometimes people make a mistake. Because this is plus, and right here we have the plus, this is multiplication, so the z to the 1/2 is going to go in the numerator. Now, if we look at the next example, it's the same problem, except for now, instead of adding the 1/2 log z, we're going to subtract this. So to start out, we're going to do the exact same step where we would have log x squared minus log y cubed minus log z to the 1/2. So now I want to see if you can figure out how to combine this to one logarithm. So once again, we would take the log of x squared, and because of the subtraction, the y cubed again is still going to go on the bottom. And now notice this one is being subtracted. And because this piece is subtracted, that means we're going to divide. So that piece as well is going to go on the bottom. So that would be z to the 1/2 in the denominator. And this here is your answer. Or once again, you could change it back to a square root where you have the square root of z. So look at the difference here where we subtract the log z to the 1/2. Because we're subtracting again, that means it's going to go in the bottom. Whereas in the previous example, we had addition, so therefore you're multiplying, so that z to the 1/2 went in the numerator. So that's one way to remember it. If you are adding, it's going to go in the numerator. If you're subtracting, it's going to go in the denominator. So that's why here it's minus log of y cubed. So the minus says the y cube's in the bottom, minus log of z to the 1/2. Again, the minus says the term is going to go in the bottom. All right, now we have another example of condensing. And notice here we have 1/3, and that's being multiplied by everything because of the brackets. 2 ln of x minus 4 ln of y minus the natural log of z plus 2. Now notice here the parentheses. We're taking the natural log of z plus 2. So the first piece I would start with is the inside here. Because the 1/3 is applied to everything, you could distribute the 1/3 and you would get 2/3, 4/3, and 1/3, but you're going to find it easier when you're condensing, if you have a term that is applied to everything, to go ahead and leave that to the very end, because we know this is going to turn out to be an exponent at some point. So I would first take care of the exponent on the 2 here, so move that over, and we would have the natural log of x squared minus the natural log of y to the 4th minus the natural log of z plus 2. Now be careful with this natural log of z plus 2. This is a little bit different, and there's really not a whole lot we can do with this to simplify this piece. Because notice, this is not one of our properties, so be very careful. A lot of times people confuse this. We don't have a log of z plus 2. If you go back and look at these properties carefully, it says log of u plus the log of v is equal to multiplication. We don't have anything where we're taking the log of u plus v. All we have is the log of u times v, or u divided by v. We don't have a log of u plus v. So be very careful with this example. All right, so now, again, we're going to leave the 1/3 to the end. We can condense the 3 natural logs together. So we could write this as the natural log of x squared. And because of the subtraction, that means the y to the 4th is going to go on the bottom. And we have more subtraction, so that means the z plus 2, and again, that's going to be treated because of the parentheses as one term. So the z plus 2 will also go in the bottom, again, due to the subtraction. And now all we have left is the 1/3, and this 1/3 can be moved up here as the exponent. So you would end up with the natural log of x squared divided by y to the 4th multiplied by z plus 2, and then all of this is raised to the 1/3 power. And once again, if you prefer, we could actually write this as the natural log of the cube root, because remember the 1/3 is representing the cube root of x squared over y to the 4th times z plus 2. So again, either way would be correct. So here we've looked at how we can expand and how we condense our logarithms. So make sure that you go back and you really understand these 3 properties.